So here, ladies and gentlemen, are the derivatives of these 6 inverse trigonometric functions. If you're interested to know where these come from, there's a supplemental video that I've posted that you're welcome to watch, but is not required. Also, I'll mention, if you had trouble finding the video that comes before this is part 2. If you didn't find part 1, I recorded it with a different piece of software, so you can find a link in the Moodle, or you can search on YouTube. It's called 3.7 Derivatives of Inverse Functions, part 1. All right, so you will want to pause the video and write these 6 derivative formulas into your notes. Notice that for the first time, this is the first time we've learned a new derivative formula since we learned about the chain rule. Our derivative formulas are given using the chain rule. So instead of telling you what to do if I wanted to take the derivative of inverse sine of x, I'm going to tell you what to do if you have to take the inverse sine of some function of x, which we're going to call u. So copy these down and we'll do some practice in a second. All right, so a couple examples now that we know our formulas. Here, I've been asked to take the derivative with respect to x of inverse sine of x squared. So remember that our formula now, our derivative formula, has the chain rule built in. So I have to ask myself, in this problem, what is having its inverse sine taken? That's going to be my u. So I would say in this case, u is going to equal x squared. So now when I find the derivative of inverse sine of x squared, that's going to be, let's find my formula. My formula says that's going to be 1 over the square root of 1 minus u squared times the derivative of u with respect to x. Well, du dx, if u is x squared, is 2x. That's an x. But important rule, if our original problem only has one variable in it, x's, I'm expected to give my answer with just that one same variable. So make sure we come back through here. That u was just a substitution I was doing in my mind. I'm going to take that u and replace it with x squared. So instead of u getting squared, x squared is going to get squared times 2x. Feel free to leave your answer like this. If you have the multiple choice section of the test, I would expect that the answer would be simplified to this, 2x over square root of 1 minus x to the 4th, but not required in the free response section. Here I have a problem. I have the particle that's moving along the x-axis, and I've been given a formula for its position function. So position is inverse tangent of square root of t. And the question is, what's the velocity of the particle when t equals 16? So the velocity is going to be the derivative of position. Position here has been given with the formula, the function named x. Essentially what I'm looking for is x prime of 16. So don't try to tell me x prime of 16 until you can give me a formula for x prime of t. So x prime of t, the velocity, is going to be, well, I'm going to have to take the derivative of an inverse tangent function. So I'm going to stop and ask myself, because now I know how to use the chain rule with my derivative rule. What is getting inverse tangented? That's not a real word. Inverse tangented. That's radical t. So I'm going to just make myself a note that u in this case is square root of t, or I could have written t to the 1/2. So du dx, I'm going to need du dx pretty soon, so I'm going to find it first here. Du dx is going to equal, you could write 1/2 t to the negative 1/2, or that's the same as 1 over 2 times the square root of t. Either one, totally acceptable. All right, so now it's time to actually take the derivative. The derivative of the inverse tangent of u is 1 over 1 plus u squared. I'm going to multiply that by du dx. Well, I'm sorry, du dt in this case. The derivative of u with respect to t is 1 over 2 times the square root of t. Let me just be really clear, that's a 2 and not a funny 3. So I wouldn't leave two variables in my answer, especially when there was only one variable in the original problem. So x prime of t is going to equal 1 over 1 plus, u is supposed to get squared, but what's u? It's square root of t. What's square root of t squared? Just t. So my derivative, x prime of t, is 1 over 1 plus t times 1 over 2 times the square root of t. My next job is to find the velocity. Remember, I was looking for x prime of 16. So x prime of 16 is going to equal 1 over 1 plus 16 times 1 over 2 times square root of 16. Square root of 16 is 4. 2 times 4 is 8. So this is 1 over 17 times 8, whatever 17 times 8 is. I got one more example. What if I want to find the derivative with respect to x of inverse secant of 5x to the 4th? Well, I'm going to remember that I have the chain rule built into my derivative formulas now. My u in this case, it's whatever is getting inverse secanted. So that would be 5x to the 4th. Du dx, which I will need, is going to be 20 x to the 3rd. That was the 4 coming down to the front and multiplying with the 5 that was already there. And then my new exponent is 1 less than the old exponent. All right, so this derivative that I'm looking for is going to be, look at my formula, right? It's 1 over the absolute value of u times the square root of u squared minus 1 times du dx. That's the formula. That's what you're committing to memory. Now we're going to replace all the u's with 5x to the 4th. So this is 1 over the absolute value of 5x to the 4th times the square root of 5x to the 4th all squared minus 1 times du dx, we said was 20x cubed, which you could feel free to leave just like that, or you could simplify here. This is going to be 20x cubed over the absolute value of 5x to the 4th times the square root of 5x to the 4th squared is 25x to the 8th minus 1. Final answer. So I'll point out one last thing. These are the derivatives of the 6 inverse trigonometric functions. It looks like a lot of new stuff to memorize. So let me just point out. I have these lined up so that across from each other are the co-functions. Here I have the derivative of inverse sine. The co-function of sine is cosine. So here's the derivative of inverse cosine. Notice that they are exactly the same, except they're opposites. Which means they're not exactly the same, they're opposites. But now that's about half as much stuff to memorize. So the derivative of inverse cotangent is the opposite of the derivative of inverse tangent. So use that to help you to memorize these functions.